The last of our four basic operations is division. So that's what we're going to introduce today. And I know I'm not super big on definitions, and I really don't need you to memorize this, but I am going to put this up because when we start talking about dividing by zero and what happens with that, it's really nice to have this definition. So our definition that we have, and I'll reference back to this in a little bit, A divided by B equals C if and only if C is a unique whole number, I should say, such that B times C equals A. So we really think about this in terms of division, in terms of multiplication. So you have to understand multiplication before we really can understand division. We have a couple different ways we might see division written. So we've got our traditional division sign. We also can think about it being fractions. So when we go to have to type I know it's not right now, but when we have to go to type fractions in our calculator, we do that by hitting the division symbol. And then eventually in this section, we are going to get to that long division. So we will work on that. So those are all the different ways to write this. So in the format I have right here, A is considered the dividend, B is the divisor, and C, the answer. I'll put that up there. All of these are equal to C, is the quotient. So we call the answer a quotient. Like the answer for addition is the sum, the answer for multiplication is the product, the answer for subtraction is the difference, the quotient is their answer part of division. Like we've seen on a lot of these operations, we're going to start with our methods, things that introduce our division so we understand what that symbol actually means. So the first is to think about a set partition, so breaking things into sets. So for instance, I'm going to write out a word problem that would kind of be using division in terms of a set partition, and I'll draw a picture as well. So for this one, let's say there are 12 students in a class, but only 4 computers or tablets. We'll say tablets nowadays. How many rotations will we need for all the students to have access to a tablet? And we'll just put to share the tablets. So we're thinking about taking that whole class and dividing it into these smaller groups, these smaller sets here. Now, I'm not going to draw 12 people, students. That would take me a while. I'm not very good at drawing. But I can represent them with X's. So there's 12 X's. There are 4 computers, or tablets per rotation. So I can put 4 in a group, and there are 3 groups. So this dividing is taking a set and figuring out how many groups could be made out of the larger set. We also can think about division in terms of multiplication, kind of like the definition set up above. So maybe I would have the problem 20 divided by 5. I could rewrite this as a multiplication problem. I'm going to multiply the 5 times the something would give me that answer of 20. And the order for the multiplication doesn't matter. But 20, the product, does matter. That product is the same thing as that dividend that we had up above. So that 20 had to be the answer. Whatever was that first in that division statement had to be the answer for my multiplication statement. I know when we looked at multiplication, we said that multiplication was repeated addition. If I had to add something over and over and over again, that would get really old. So we came up with a shorthand for that, which was multiplication. Same thing with subtraction. If I had a whole bunch of things you know, maybe I had 500 pencils and I was giving everybody 5 pencils, you know, during that, giving you 5, somebody else 5, somebody else 5, and subtracting 5 over and over and over again, and trying to figure out how many people I could give it to, I would have to subtract 5 100 times. That would get really tedious. So instead of subtracting a whole bunch, we can divide. So I'll keep with this 20 divided by 5 idea here. So I could take 20 and I can subtract 5. So I subtracted 5 there. And I can keep subtracting 5 until I get down to 0. So we can see actually I do that act of subtracting 5 4 times. So it shows that 20 divided by 5 is 4. We also saw our fact family before. We were looking at addition and subtraction. We could have a fact family for multiplication and division. So again, I'll just stick with the same problem. 20 divided by 5. We just saw the answer was 4. I can keep these same 3 numbers and write 4 facts out of them. There are always 2 multiplication facts and 2 division facts. So all the different ways you can write using just those same 3 numbers would be our fact family.